combinational logic. Again, those who have not taken pen paper, please take a pen paper, because without that this is not possible. And this topic will be for your practical on microwind also. So this is the basic concept for implementing anything on the microwind, that is the combinational logic. So 6th point, that is CMOS combinational logic. Those who are not having pen paper with them, just take your pen paper. So what is the learning objective or outcome of this thing? So after completing this particular point or lecture, you will be able to design any combinational logic in terms of CMOS circuit. Means if I am saying AND gate, you need to implement, so you'll be able to implement that AND gate using CMOS circuitry. Okay, so explain working of CMOS combinational logic, and all after drawing this particular AND gate, you will be able to explain the working, how this is giving AND gate output. Likewise, or for complementary metal oxide semiconductor, it is dominantly used because of several advantages it is having, like a low power consumption, packaging density is more, and low cost. Next, PMOS should be always connected in pull-up network, and NMOS should be connected in pull-down network, because PMOS passes strong 1 and NMOS passes strong 0. Justification, you should do the practice of that. So PMOS turns on when 0 is applied, and NMOS turns on when 1 is applied. And this is the way that is PMOS passes. This table is very, very important. Just remember this table. Okay. And always at a time only PMOS will be on or NMOS will be on. Both will not be on, as it is a complementary. So moving forward to the combination logic. So hope you are having pen paper with you. So this particular PPT I have already covered. What is meant by this? Again, I am repeating and doing it fast. So always PMOS is connected in pull-up network, means it should be connected in to the side of VDD, that is logic 1. NMOS should be connected in pull-down network. It should be connected to the side of VSS. In between that, whatever the link is present where you are getting the output, and inputs are combined together to form to give the common input. So this way, PMOS might be, there are n number of PMOS devices or 3 number of NMOS devices that might be connected in parallel or series. It is not like that only series it is connected or parallel it is connected. It might be in the any combination. Same way for the NMOS. So pull-up network is used to make output as a logic high, because pull-up network to make logic high, because this is acting as a switch only, and that's why when it is on, VDD will apply to the output. And related to pull down, as this is on, this will be off, because I told you complementary type of arrangement, at a time only one will be on, and that's why if this is on, means capacitor will discharge and output will be 0. PMOS passes strong 1, and that's why it is connected in pull-up network, and NMOS passes strong 0 over here. Now I told you related to this W/L ratio, it should be higher for PMOS and lower for NMOS, means it should be twice of that NMOS. PMOS W/L ratio, that is width to length ratio, should be twice or 2.5 times that of the NMOS, because NMOS is having electrons as a majority charge carrier and mobility of electron is more. To have same amount of current or resistivity, to have equal on-off time, we require PMOS to be have more W/L ratio than the NMOS. So I have cleared that using graph in the last lecture only. So this is the PMOS is connected in pull-up network and NMOS is connected in pull-down network. And at a time, only one device is on. So now what is the pros and cons? That also we have studied that why CMOS is prominently used. So we are recalling this. So CMOS dissipates very less amount of power, low static power consumption. This particular point is again detail present in the next PPTs, but for this moment, just remember that both the devices are not on at a time. That's why it never draws the more power. So only the leakage current, whatever present, because of that, what are the power consumption, that is called as the static power consumption, and which is very negligible. CMOS do not degrade output for both logic 1 and logic 0. So as I told you, maximum swing you are available, you are getting, that is logic 1 means 5 volt you are getting, as you are passing, PMOS passes strong 1 and NMOS passes strong 0, so I am getting 0 as the minimum voltage. So maximum voltage swing I am having from 0 to 5 volt. CMOS circuit have moderate moderate high, sorry, need to remove this. Fan in and fan out means I can connect medium number of device at the output because it gives low output current, and that's why if I'm connecting more devices, so as more devices are connected, it will take current, and it is not proper to connect because it gives less output current. So high noise immunity, this concept also I tell in coming PPTs. Fabricating a PMOS, a CMOS chip is well established, means process is established, well established, so it easily can fabricate. CMOS cost of fabrication is less, more denser, so in small area you may have more complex device present over here. Reduce the complexity of circuitry because connections at over there, so because of lower density, the complexity will be somewhat less. What is the problem? Only the problem is that you require twice more transistors. Suppose if I am using NMOS, so I need to use only 2 NMOS, but here I need to use 4 NMOS means plus PMOS means I require twice transistor, to double transistor. So that we will see in the coming PPT. Now, this is very, very important. Just write in your notebook because the assignment question will be like this. You need to implement any 5 variable combinational circuit. 5 variable, any combinational circuit you can design. So now for that, what are the rules? You are not able to directly design the combination circuit. So there are some rules for the combination circuit to design. So this table is very important. Now what is meant by this table? First thing, whenever you are implementing any combinational logic, it will be implemented as a complement of the circuit. Means I am not able to design AND gate directly. I am not able to design OR gate directly, but I can design NAND gate or NOR gate directly. Okay, I am able to design its OR gate, but it will be somewhat more circuitry you require. So always whatever circuit implemented is the complemented circuit. Now, next thing, two important rules. If you are to design any combinational circuit, first thing is clear in your mind that you require PMOS and NMOS. So PMOS should be connected in pull-up network and NMOS should be connected in pull-down network. So in which way you can connect? If I am having NMOS, so whether to connect in series or whether to connect it in parallel, that I need to define. For that, this is the table. If NMOS, I need to connect. If A into B, that is the multiplication is there, so NMOS should be connected in series. Okay, in AND gate, A into B. So I am having A into B. A into B means multiplication. So NMOS should be connected in series in that case. And if A plus B is there, so NMOS should be connected in parallel. So when multiplication sign is there, NMOS should be connected in series, and in positive sign, plus sign is there, NMOS should be connected in parallel. Just remember only this, just opposite of that you need to do for the PMOS. If you are trying to remember both the things, so it will be in confusion state that whether it is for series parallel. So don't get confused, just remember any one, opposite of that will be for the other. So just remember, in my case I am remembering for the NMOS because it is directly related, because NMOS multiplication means series, addition means parallel. So here same is mentioned. If NMOS devices you need to connect, so if A into B, that is product, you need to define, so it is defined in this way, that is the series. And if you need to define in the plus sign, that is addition, so you need to define in this parallel way. So this direction might be different, means it is showing like this and this is like this, you can make like this also. So there is no such problem in that. So now just tell me, this NMOS is in series and parallel, it's okay, but where to connect NMOS? Always remember, NMOS should be connected in pull down network. So that is more important, and there is no bubble. Most of the time students are drawing bubbles at both the points, no bubble at any point. So they are only drawing NMOS or only drawing PMOS. So functionality will be totally wrong. Although they are saying, thinking that I have just not drawn bubble, what is the matter in that? But think in the way of working. So hope this thing is clear. Second, PMOS should be connected in series if A plus B is there. That is addition is there, and it should be connected in parallel if multiplication sign is there. So exactly opposite to this. That's why I told you, don't remember, try to remember this at the same time. Just remember one, and we'll be having opposite of that for the next. So this, hope this particular rule is clear to you, and this is very important from the point of view of your lab as well as designing of any combinational circuit. If this is not clear, nothing will be understood by you. So always remember, this is the rule that in NMOS, for NMOS, when multiplication is there, it will be in series, and positive plus के लिए it is in parallel. Opposite of that you are having for the PMOS. NMOS is connected in pull-up network, PMOS is connected in pull-down network. Always whenever you are implementing any CMOS circuitry, it will be implemented as a complemented circuit. What is meaning of this? I will tell you in the coming PPT. So hope this is clear. So I am able to implement directly this NAND NOR XOR function. But if I want to implement AND or XOR, I need to connect one inverter in front of this, because whenever I am implementing any circuitry, it is implemented as an inverted circuit. Okay, just remember this. I will explore this thing again. So this is very important. Hope you have drawn that in your book. So with me, you need to draw the circuitry. So first we'll be taking easy, that is CMOS. Now, how we have drawn this diagram? So you know this thing in your mind, that always in PMOS, pull-up network, PMOS should be connected, and for the pull-down network, NMOS should be connected. In intermediate, we need to make a common point, and we have to take output. VDD is connected to PMOS, VSS, that is ground, is connected to NMOS, and inputs are common. Now, how to define how many NMOS and how many PMOS required? So that will be depending upon this, how many variables you are having. So in inverter, always you are having one input and you are getting one output. So as variable is one, A. Here we are considering my input is A, so my output is A bar, that is denoted by A dash. Okay. So I am having only one variable, so I require one PMOS and one NMOS. Okay. So I am having one PMOS, I am having one NMOS. Now how to connect? That always PMOS should be connected in pull-up network. So in this I have placed PMOS, and here I have placed NMOS. Now I need to take out the output point, and that's why we have combined these terminals with each other to form an output. So this is my Q. Now here is what mentioned, that input should be connected to give single input, because inverter requires only one input. So I need to combine this input with each other, and I am giving A. So my output will be what? As VDD is connected to pull-up network, that is PMOS, and VSS is connected to pull-down network, that is ground. So what will happen? As we have already studied, inverter means it inverts the output. So if I am giving logic 0, what will happen? Active low device. So this will be on. So as this will be on, what will happen? This will be on. So at the same time, this will be off, and that's why my output will become VDD. So that is logic 1. So when I am giving 0, my output is 1. But whenever I am giving 1, what will happen? This will be off, and at that time this will be on, and that's why output will be connected to this, because these are acting as a switches only, connection and removing. So that's why output is 0. So hope this thing is clear. So by this also I have proved that this will be on, this will be on, and what is the output. So this way we have seen that inverter using CMOS, how you can implement inverter. So next lecture I will be continuing the further points, because it's now 3:54. Hardly 1 minute we are having, because next session is planned. So before moving to the next point, I just want to recall the things, that always PMOS should be connected in pull-up network and NMOS should be connected in pull-down network. And for NMOS, when A plus B, like this, any variables are coming, NMOS should be connected in series, and if A plus B type things are coming, it should be connected in parallel. If you have cleared this particular point in your mind, you can try for this, how I have designed. Just try for this, and you need to draw this table also, so as to find out whether my output is 1 or 0. So this is what basically NAND gate. So NAND gate means A into B. A into B means multiplication, so NMOS should be in series. So they are connected in series. Why two NMOS are taken? Because there are two variables, A and B, and that's why in series. Now next, what opposite to that in the PMOS? So PMOS should be connected in parallel. So they are connected in parallel. Interconnection points that is forming over here, which is your output, and A should be connected to A and B should be connected to B. Likewise, you can draw the circuitry. Always PMOS should be connected in pull-up network and NMOS should be connected in pull-down network. Now, depending upon what input combination you are giving, because there are two inputs, means there are four combination, 0, 0, 0, 1, 1, 0, 1, 1, and that way just think which device is on, and that way you need to write this particular combination. And depending upon the circuit you are getting, so what output you are getting, you need to think. So this particular table is very important. So hope the things are clear, and just do the practice, because without practice this particular topic understanding is very difficult. So I'm just again and again telling you, just repeat this particular point in your notebook.